Hi everyone, I'm Mrs. Snook. I'm one of the 3 pre-AP chemistry teachers. Today you're going to take your first set of notes in a flipped environment. So when we set up our notebook, what I suggest you do is why don't you leave the first couple of pages blank, and you might want to do a table of contents with that. 2 to 3 pages blank would be ideal. Then when you start taking notes, you will write your notes on the right side. So you have your notebook and say this is your spiral. You are going to take notes on the right. And then on the left in class, you will do activities, practice problems, etc. So today, skip a few pages and start on the right. So our first unit contains a lot of information. What's good about it is that some things are going to be a review for you. So today I'm going to be talking to you a little bit about properties of matter and then also physical properties of matter. Our element quiz will be Wednesday the 16th. Our summative quiz will be on Monday the 21st. And our first major project, this is your first major grade, that will be due on the 23rd of September. You will see here that there is not a test for Unit 1, and that is how pre-AP chemistry will be from time to time. We will not have a test unless it is from the district, at least in the first 9 weeks. So, you will need to memorize some of the elements that we will use throughout the school year. These are common elements. These are the ones that we will work with quite a bit. We'll work on bonding with them, etc. So the periodic table that I'm going to show you is in your Schoology materials. And I'm going to give you a visual of what it is and explain which elements you need to memorize. So it's the name, symbol, and spelling of it only. Please do not memorize any atomic numbers or atomic masses. Nor do you need to memorize where these elements are on the periodic table. So this is the periodic table that you will be given, or it's in Schoology. You can see here that for any element it does not have its name on it. It's just the chemical symbol. Always starts with a capital letter, and of course in some cases there are more than 2 letters, but only 1 capital. So the first thing that we're asking you to do is memorize from 1 down to 38, which is strontium. So that means all of the first row, or we call it a period or series, 2, 3, 4, and then down to number 38. We also ask you to know all of Group 1, Group 2, 17, and 18. So the groups, remembering back from 8th grade, your vertical columns are your group numbers. So those are your groups or families on the periodic table. So you're responsible for 1 all the way down to 87. For Group 2, beryllium, down to 88. Group 17, we typically stop here at AT, but you can go to TS. And then Group 18, these are what we call the noble gases, which I'm sure you remember, and you should memorize those at least to 86. Then there are other elements that you can see here, and these are just various metals that are very common and important. So they're kind of spread throughout the periodic table. You can see here, and then of course uranium. So I would locate those on your periodic table and get those memorized. Okay, your first element quiz, like I said, will be on Wednesday the 16th. So what is chemistry? Chemistry is a study of matter's properties and the study of matter's changes. Matter is made up of atoms that have mass and volume. And volume means that it takes up space. you should probably remember a science concept that involves mass and volume. So that's something to discuss with your teachers in class. So what is a property? Keep it pretty simple. It describes a substance. Some can be measured, which means it's a quantitative property, meaning quantitative quantity, an amount. Most can be observed, more on the qualitative side. Some can be used to identify a substance, and these are pretty interesting, and we will talk a lot about them in this unit and throughout the year. So some properties can be used to identify a substance. We will study physical properties and chemical properties. So everything on this slide is very important for you to know. So if you abbreviate, you write word for word, whatever you need to do, these are important statements. I would try to learn, you all text, so I know you can shorten or abbreviate, but for taking notes, and this is going to help you throughout your life, you might want to, start figuring out some abbreviations. So maybe physical physical properties, chem, and your teachers will abbreviate chem all the time. So if you can find ways to abbreviate, that would be ideal. Saves you lots of time. So these are your chemical, these are physical property and chemical property. Next, we are going to just focus on physical properties right now. And here are some physical properties. I'm going to go into detail on each one. If you draw this diagram here, you should probably leave some space at the end here, because if you don't know what the definition is, I'm going to give you the definition. So we have intensive physical properties and also extensive physical properties. And I have to define these two words for you. Later, after we're done with physical properties, we are going to add chemical properties under the intensive column. So let's get started. Intensive properties. This is something that this property remains the same when a substance changes in size. So it doesn't matter the mass of it for the property. The property stays the same. Another term you can use is intrinsic. Intrinsic properties. So some of them, not all, can be used to identify a pure substance. And a pure substance would be either an element or a compound. And some of those would be density, boiling point, melting point, and of course what you remember from biology, DNA. And you know that your DNA, unless you're an identical twin, your DNA is specific to you, which means if someone has a sample of your DNA and tests it, they can identify you based on your DNA. That's kind of keeping it very simple. Hopefully that gets the point across. So intensive properties, some of them can identify a pure substance. And of course it can be either physical or chemical. So here are some intensive properties of matter, and we have like color and the odor. I know we don't spell it the British way, odor. Luster, that means that something is shiny. Melting or boiling point. So these are just some properties that they don't change with how much of it you have. But not all of these can identify a substance, because as you know, there are a lot of shiny or lustrous metals. You know that. So luster, if something has luster or not, cannot identify. But there are a few on here that do, and that's what we're going to talk about a little later. So here, these are just some definitions. You may already know them, but here are some intensive physical properties. And none of these can ID a substance. So we have a phase or state of matter. You can say either one. And of course, solid, liquid, gas, and most of you have heard of plasma also. We'll focus on these three. Luster just means that something is shiny. And if something is malleable, it can be pounded into sheets. Great example in most of your kitchens would be aluminum foil. Some other intensive physical properties would be if it's conductive or not. So the ability to transfer thermal, which means heat, energy, or electricity. If something is ductile, that means it can be drawn into wires. So think of jewelry, copper wiring, things of that nature. A new term for you, most likely, is viscosity. And viscosity is the resistance of a liquid to flow. Your teacher will talk to you a little bit about that in class. Just think of it as something like comparing syrup versus water, or molasses versus water, if you know what molasses is. It's just that resistance to flow. We have the term brittle, ability to break or shatter easily. We have a new term for you, which would be volatile or volatility. And that is the tendency for a substance to vaporize at normal or room temperature. And you should all know that to vaporize, that is the phase change, the phase change from a liquid to a gas. So liquid to gas. And remember, try to use your abbreviations here. So liquid converting into a gas. If a substance is non-volatile, that means it doesn't vaporize at normal or room temperatures. The last one is color. Now, we do have some intensive physical properties that can identify a substance, and these are very specific to a substance. So we have the melting point or the freezing point, and it's the same temperature, the temperature at which a substance melts and freezes. And then the other important one regarding phase changes would be the boiling point or the condensation point. And that is a temperature at which a substance boils and condenses. So of course, if something melts, we are going to go from a solid to a liquid. If it freezes, of course, it's the opposite, liquid to a solid. Another physical property, and there are actually two here, but I know you know this one very well, is called density, and we give it the variable capital D. And density is the relationship between the mass of a substance and its volume. And I would hope you would all remember that the mathematical equation for solving for density is mass divided by volume. This is a new term that we will address quite a bit in the second semester, and it's called specific heat capacity. The variable is a C. And that is the amount of heat required to raise 1 gram of water 1 degree Celsius. Okay, so did not want to talk about that yet. That's what you'll do in class. So here we have extensive physical properties, and we're almost done here. So extensive physical properties are properties that are dependent on the amount of the substance present. They can be measured, and they're measured with different instruments in a lab. They cannot be used to identify a substance. Very, 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 very important. What I typically say is what the height of a person is. That is an extensive property. It depends on how much of you there is. So height is an extensive property. Well, I am about 5'7". We'll say I'm 5'7", 5 feet 7 inches. Well, there are quite a few people on the planet who are also 5 feet 7 inches tall. So that means height or a length cannot identify a substance, and we call those extensive physical properties. They do depend on the amount of the substance present. We have 3 of them that we will discuss in class, and they are mass, volume, and length. That's it, just 3 of them. Mass, we would measure with an electronic scale or like a triple beam balance. We have a graduated cylinder for finding the volume of a liquid. And then, of course, we would use the metric side of a ruler, and we could find the volume of a substance. We would take our measurements and multiply. So that is basically the conclusion of this video. If you do not know what these terms mean, you can write them down. What's really important here is that we are using units. In chemistry, we say no naked numbers, which means every measurement must have a unit or a letter behind it, and that letter indicates what the measurement is, what possibly like the type of instrument that we used. For example, if we are measuring the volume of a liquid and it has a ml or an L behind it, we most likely used a graduated cylinder. Centimeters cubed, that would be something, a measurement made using a ruler. Not always, but that's pretty much how we will use it in our class.